Section 3.2, periodic function. A swing goes forward and backward again and again. Because the swing system is not perfect in preserving momentum, it will slow down eventually. But imagine if it did not. How cool would that be? If I graph the position of the perfect swing as a function of time, so y will be the position and x will be time, I will get something like the graph on the left, where it goes up, down, and repeats again and again. Any function that repeats, smoothly or not, is a periodic function. The graph on the right shows you one cycle. If you trace the curve from left to right, so it starts here, and you can see it goes up, it goes down, and by the time the curve go back to the beginning here, like the same level as the beginning, this is one cycle. So make sure if you go up and down that you always have to go back at the beginning. Because for example, this is not a complete cycle, right? Because then you're only focusing on the up part but not the down part. The period, represented by the letter P, is the length of one cycle and is always on the x-axis. And in the video, you sometimes will hear me refer to the period as how far did it go. Because if you go from the start to the end, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 units in total from the beginning to the end, so this period is 16. Frequency, on the other hand, represented by the letter F, will always equal to 1 over P. In this case, frequency will equals to 1 over 16, and like any other fraction, you are free to turn it into a decimal number, 1 divided by 16, which is 0.0625. Another example of a periodic function would be the position of the sun. Look out and note the position of the sun, and if it's nighttime, note the position of the moon in the sky. A complete cycle would be when you can see the sun or the moon at the same position again. In this case, the period is 24 hours a day, and the frequency is 1 over 24 hours. You can leave it as a fraction or turn it into a decimal number. Periodic function is not always a smooth curve. Any function whose graph is composed of repetitive pattern is a periodic function. So in the next page, you will see 3 graphs. In each graph, I give you a complete cycle, and what I would like you to do is basically graph 2 more cycles to the right. I would like you to do it carefully by looking and analyze like how, for example, the stretch, it goes from the very top at 2 to the very bottom at -2. But I don't want you to just go downward anywhere. I would like you to analyze it carefully and discover that, okay, it takes 5 spots for it reach from the very top to the very bottom. And then to repeat that exact same thing again and again in order to extend the cycle that you see there. Right, so, oops, didn't mean to show you that because that was the answer I was leaving for the next video. So whenever you're ready, try this exercise. And when you're done, click on the next video.